So we've been talking about similar triangles and how they're proportional and how you can set up proportions and solve them. What we're going to do today is we're going to take a look at some word problems where you can do exactly that. So the idea in an application application means you're going to apply what you've just learned, and we're going to apply it to real life situations. So I want to show you in the notes today some examples of what would create similar triangles in real life situations or in word problems. And then we'll turn each one into an example and we'll solve it. Now, the first real good example of similar triangles is shadows. So if you have two things standing next to each other and they both cast a shadow from the sun, then basically you're creating similar triangles. So here's a picture of that. There's a person and a tree, and each one is casting a shadow. Now in the picture, all you can see is the triangle. So let's be a little bit more specific. Let's say the sun is up here somewhere. So as the sun's rays come down, it hits the ground, and as it passes the top of each shape, in this case the tree, it's going to create the shadow of the tree down here. So in your triangle, one side of the triangle is the tree, one side is the shadow, and one side isn't actually there. You have to imagine the sun scraping across the top of the tree and hitting at the end of the shadow. And then the same thing with the person. So up here is the sun, and this line right here, I'll highlight both of them in kind of a dark yellow. This line I'm highlighting in yellow is the one where you wouldn't actually see that. That's just the sun passing across the person's head and hitting the ground, and that shows you where the tip of the shadow is for the person. But the idea is when that happens, it creates similar triangles. So we get proportions, and you can match up the sides. So like the height of the tree matches up with the height of the person. That's a 5 and an X. And the length of the two shadows match up. So if I wanted to solve this, I would set up a proportion. I would do probably, it doesn't matter which one. I'll go with the purple one first, and I'll say X over 5 equals, and then the green one, 26 over 6.5. Now, once you've gotten the proportion set up, we always solve it the same way. This is our third day in a row. We're solving by cross multiplying. So I'm going to multiply one diagonal, X times 6.5, say equals, and then multiply the other diagonal, 5 times 26. Now X times 6.5 is 6.5X. 5 times 26 is 130. And then to finish out the question, we would just divide by 6.5. And because this one, and word problems do tend to have decimals in them, so you're welcome to use a calculator for this one. But 130 divided by 6.5 ends up being exactly 20. So what we just figured out is that tree is 20 feet tall. And that's because we knew that the two triangles in the picture were similar, and we set up a proportion and solve. Okay, here is another situation that creates similar triangles. So when you're looking at a reflection in a mirror, but you're not looking straight at the mirror, you're looking at an angle, that can also create similar triangles. So in this picture, what you've done is you have this person who's 5 feet tall. He set up a mirror on the ground, and he walked to a point where he could see in the mirror the top of a flagpole. And he's using that to measure how tall the flagpole is. Well, again, once you realize that those are similar triangles because it's a reflection in a mirror, then you can match up the same way we just did. You can match up the height of the person with the height of the flag, and you can match up the length of the distance to the mirror from the person and from the flag. It's basically kind of inverted similar triangles. They are similar, but they're reflections of each other. So the H and the 5 match up, and the 24 and the 8 match up. Now let's solve it the exact same way we just did. I'll start with purple, h over 5, equals green, 24 over 8. And remember, I mentioned this in the last video, make sure you're going in the same order. If I start with the h over here on top of my first fraction, I have to have the 24 on top of my second fraction. If you switch triangles in the middle, you end up not getting the right answer. Okay, so let's solve, cross multiply again. We have h times 8 equals, and then for our other one, we have 5 times 24. Now h times 8, of course, is 8h. 5 times 24 is going to be 120. We'll divide by 8 and we'll be done. So this time h ends up being 15. And again, we just figured out how tall that flagpole is. It's 15 feet tall. So what we're doing is we are recognizing similar triangles in word problems, and then we're setting up proportions and solving exactly like we've been doing for 3 days in a row now. All right, here's another one. I call this one the triangle inside a triangle. And here's an example of what I'm talking about. So what you're going to see, and I'll draw kind of a separate problem here. What I mean by triangle inside a triangle is a lot of times you'll have this triangle here, and then there will be another line going through it like this. So the small triangle is this red one right here. The big triangle is the whole thing. And those two end up being similar. So a lot of times in this situation, this one can be a little bit confusing. It might help you to draw them separately. So let's do that. If I take these two triangles, if I draw just the small one, it looks like this. It's a right triangle. It has a 10 here and a 2 here. That's this triangle right there. Now, if I draw the whole triangle without the line down the middle is the part that's a little bit confusing. What I have is 70. Now see this line here and here means 70 goes all the way across. So this whole side here is 70. And see that where it says how deep? This is basically the wording of this question. If this was a word problem, it might be like you're at the ocean and you're trying to measure how deep it is as it slants down. But basically, your x is going to be right here because how deep is the side you're trying to find. That becomes your x. Now, once you recognize that, either just by looking at it or by redrawing them like I did, it's the exact same thing we just did. You have a 10 and a 70. These are similar triangles. We'll match up those. And you have a 2 and an x. So let's set it up. And I remember I told you guys in the last day of notes, I always like when I'm setting mine up doing the bigger triangle over the smaller one. So I'm going to do 70 over 10 for my purple fraction, and I'm going to do x over 2 for my blue one, or for my green one. And that's how I know I'm not going to get them switched around. Now for the third time today, and for the 20th time over the last few days, we're going to cross multiply again. So I do 70 times 2. I do 10 times x, and I solve. 70 times 2 is 140. 10 times x is 10x. Divide both sides by 10, cancel that out, and we get 14. And that's the answer to the question. That ocean 70 feet out, or 70 meters out, is actually, I answered it in feet. It should be meters. Let's fix that. So we're measuring in meters, not feet in this question. So the ocean, 70 meters out, is 14 meters deep in this situation. But again, same thing 3 times in a row. You guys are recognizing similar triangles in a problem, setting up a proportion and solving it. Now the one last one I want to show you, this one's a little bit weird. It actually gets its own theorem. It's called the angle bisector theorem. And it says if you bisect, now bisect means cut exactly in half. We saw like midpoint means kind of the same thing. To bisect means to cut exactly in half or into 2 equal pieces. So if you have this picture here, where you have a triangle, and on one of the angles, like in this picture, it's this one up here, you've cut it exactly in half into two equal pieces. Then what happens is it creates proportions. So one of my proportions comes from one of the half triangles. So like you have AC right here, and you have DC right here. So those two purple sides that I marked, I'm going to make one fraction out of that. And then the other one is this side, BA, over this side, BD. So what I want to do, instead of starting a new page, let's just turn this into a word problem. Let me say, or not even a word problem, just a math problem. Let's say this was 6 and this was 4 and this was 10 and we're trying to find out this one. Now because I already color coded it, it's easy to see. You're basically, you've split the triangle into two smaller triangles. The sides of each one make up each fraction in the proportion. So for my purple one, I might do 6 over 4. That's this one over this one. Then for my green one, it would be this one over this one. It would be x over 10. And now we can solve for the fourth time today using cross multiplying. So I have 6 times 10. I have 4 times x. And I finish the question. 6 times 10 is 60. 4 times x is 4x. We divide both sides by 4 to cancel out the 4. And x ends up equaling 15 for this one. 60 divided by 4 is 15. So that one wasn't really a word problem, but it's a theorem that does show up in word problems sometimes, so I wanted you guys to see it. But basically the main idea for today, remember you guys, what we're doing is we're looking at word problems, we're recognizing similar triangles, and then we're setting up proportions and solving.